Man, it is so hot in here. I need to cool down. I need some way to just cool down.
I know.
Oh, perfect.
I just showed it on the side.
Hey, safety glasses, guys.
Safety first.
Sorry, too far. That's our workout right there. Zoom back in. Okay, so our basic design is going to start. We have a reservoir which is filled with distilled water. We have a pump that's going to pump the cold water into our housing. The housing has copper tubes, and it's basically just a big heat exchanger. Below the housing, we have a base plate that has 10 fins with a fan blowing cold air over the fins. Leaving the housing, we have warm water going into our radiator that has a fan blowing cold air through the radiator. We have cold water coming out of the radiator and coming back into the reservoir. And that's our basic idea.
Elaborating more on the housing itself, inside the housing, we have an inlet and an outlet port for distilled water. The water travels into the plenum through the copper tube, collects heat from the mineral oil in this chamber, and through the outlet to the radiator. There's a rubber gasket used to seal the lid onto the housing, and also a rubber gasket on the base to clamp the PCB board down to the base plate. This is an original PCB board using an IGBT MOSFET transistor in the middle, in series with inlet current and outlet current. And due to the current draw on the dies, it creates heat, and also the parasitic on the wire creates heat. We modified the location of the terminals on the PCB by modifying and fabricating our own terminals and soldering them on so they can fit into the housing. On the base plate, we use aluminum, and we have 4 heat sinks purchased from Avid that have 272 fins in series on the base plate, and this is on the bottom of the housing.
So this is our full system running. We have our reservoir pumping into our casing. You can see the Arduino taking data and uploading it directly to our laptop. Water comes out of the casing into the radiator.